In this lesson, we'll learn about molar mass. Okay, think of a compound like calcium carbonate. Okay, this compound has atoms calcium, oxygen, and carbon. Well, I underlined carbon in place of oxygen and oxygen in place of carbon. So you are required to calculate the molecular mass, the molar mass of this compound. What you want to do is identify the masses of each of these atoms, that's their atomic masses, and then just add them in the exact number or the exact number of times that they are present. It means calcium just one, carbon just one, oxygen add its mass 3 times. That is all. Usually, as part of your question, you'll be told the atomic masses in a bracket. Calcium is usually given as 40 most times, carbon about 12, and oxygen about 16, most times in grams. All right. Okay, now if I want to use these values to calculate the mass of this compound, so for calcium I will just take 40. I'll add that to carbon, which is 12. Now we have 3 oxygens, so I could say 16 plus 16 plus 16, and that is the same as 16 times 3 added to this. Alright, so 16 times 3 is 48. So 40 plus 12 will have 52 plus 48. Okay, and our final answer will come out as 100. Now the unit for molar mass is gram per mole. This can also be written as gram per mole this way. That's just little mathematics. Gram per mole is same as gram per mole, and this is same as gram times 1 over mole. You know, in mathematics, when you want to multiply fractions like this, you just multiply numerator to numerator, denominator to denominator. You have that. And also, when you have something like this, think of 2. Okay, think of 1 over 2. This is the same as 2 raised to the power minus 1, right? 1 over x, same as x raised to the power minus 1. So this part of it can be written as mole raised to the power minus 1. So these and these are just the same thing. Alright, so gram per mole contains the entire meaning or the entire idea behind molar mass. It tells you the mass of 1 mole of this compound. If we have another compound, say magnesium nitrate, okay, it's a good thing we have this example so that you see how I will handle this bracket. Alright, I also have to give the atomic masses. For magnesium, the mass is 24. Usually, let's just use that. Everything here is in gram, okay? 24. Nitrogen is 14. Okay, so let's take it that way. We already have oxygen drawn from memory. All right, so we have just one magnesium here. We're writing 24 here, and then there's NO3. The bracket, okay, this bracket covers the entire N and O. All right, so it's like you have a magnesium and an NO3 with another NO. You have two different sets of NO3. This means you have 2 nitrogens and 3 plus 3, 6 oxygens. So you can see that from here. It will make sense if we interpret this as saying 2 times an invisible 1, so 2 nitrogen, So 2 times 14, I'll like a bracket there. 2 because of these two, and 14 because the atomic mass of nitrogen is 14 times 14. All right. And then for oxygen, 16 is the mass. We're using this. So I just did not write it again. Now 2 times 3 is 6. So we're having 16 as the mass times 6. Okay, so what do we have here? We have 24 plus 28. Let's find out what 16 times 6 should be. We have 96. All right, so add that to 28 and to 24. Okay, we have 148 gram per mole. Good. So this is about it. All right. If you have a molecule that is made up of only one type of atom, something like this, O2, it still works. All you need to do is to multiply the mass by 2. 16 times 2, you have 32 grams per mole. All right. And this is molar mass of oxygen. Okay. If you have carbon, carbon does not have a 2 under there. So you just go, carbon is 14. So 14 gram mole is mass of carbon. By the way, how do I know those that have 2 down there and those that don't? The ones with 2 are called diatomic elements, and you can use never have fear of eyes beer that down there. So these more like nitrogen, hydrogen, fluorine, oxygen, iodine, chlorine, bromine. Okay, those guys have 2 down there. The rest of them just stand fine on their own, at least for the first 20 elements, except sulfur, whom we can find in this form. 8. Okay, so you just have to know this. Right. Now, this molar mass can be used for many things. Say, for example, I can say for calcium carbonate, how many moles will weigh exactly 20 grams? All you need to do is calculate the molar mass of calcium carbonate, write it out that 100 grams weighs 1 mole. All right. Now, we want to know how many moles weigh exactly 20 grams. So we have a value for grams, 20. Come right under grams, write 20 grams. Then go under mole, and then you can put an X. Okay. Now, you can cross multiply X times 100 and 20 times 1. So you have X times 100, you have 100X equal 20 times 1, 20. And then you have X equal 20 over 100. Okay, so this might just go and 2. X becomes 0.2 mole. Now, if you revert, if you go back to this same relationship, this relationship works only for calcium carbonate. Moles of magnesium nitrate that would grab. You will not use 100 to 1. You will use 148 grams to 1. And that's just how it works. Okay, I'm going to introduce the concept of Avogadro. Right? Avogadro tells us the number of um, atoms in 1 mole. So if you have 1 mole of any compound, of any element, stuff like this, and you need to know how many atoms are there, well, it's just in front of you. 6.023 times 10 raised to the power 23. That is the number of atoms. Okay, let's say, for example, you want to find the number of atoms in 6 grams of carbon. All right. So what do? You cannot work with 6 grams because um, Avogadro number does not work with grams. You have to work with moles. So the first thing you would need to do is to convert these grams to mole. Now, from here, oh, sorry, this is supposed to be 12. Most times it's 12. So I will rewrite that as 12 grams per mole. All right. So if 12 gram is the mass of 1 mole, you know that 6 gram will be for half mole. So half mole times Avogadro number tells you the entire number of carbon atoms that weigh 6 grams. So this times 6.023 times 10 raised to the power 3. All right. Now, you want to do that with a calculator, you just end up dividing the 6 by 2, you get 3. And then there's a point, 0 divided by 2 is 0, 2 divided by 2, 1. And then you just put the index form by the side. And that's all. Okay,